Start over. Sorry.
Yeah, we pass over the target and actuate the system. And if we were too fast and low, a combination of altitude and speed. But if, we would exceed that rate, and so it wouldn't track the target. It would go forward to the target, say 300 or 400 feet. So then you're bombing 400 feet past your target. So the computer was trying to drop the bomb.
Oh, so this was when they went to, instead of manual.
No, we were doing over the shoulder with our computer. So we figured that all out, and then came up with a chart. If you want, to enter it with the altitude you're going to fly at and the speed, and see how much you have to
I'll be
correct
back
for
with
it.
your change for you.
And you manually correct it. You put the button just short of the target. And so anyway, we came up with it. We had this error, so we went to Republic, the tech rep, and we said we need to find out, what the error is based on airspeed and altitude. And so he contacted the factory, and a week or two later, he came back to us and said they can't calculate that. It's a year's project because it's multiple differential, all this sort of crap. Because the thing that really made it difficult was that as soon as you push the button, you'd start your maneuver. So what you had, instead of having a straight flight, you had this
Elevation.
But that was insignificant. Okay. Because the air was going so fast. By the time their controls even really made much difference, it was overload.
Okay.
So we went in then and just with graph paper and calculations, all graphing everything out, we just made up a chart that showed what the error was.
Huh. So this was different than the instrument reading that you told me about when the electronics were.
Yeah, different. Yeah, this is a different problem. We had a lot of problems with 105 that had to be corrected
before you could safely launch a nuclear bomb.
Well, before we could qualify with any criteria.
Yeah.
And but there's 3 or 4 of us working on the weapons side. The gunnery officers or whatever, that working together, we finally solved all those problems.
Huh.
Of course, we had two squadrons just finally go on nuclear alert when the Air Force back then Systems Command was in charge of all the testing and everything. The Air Force Systems Command came out with their final report that we could not drop a bomb within closer than 3,000 feet using the system. And we just finished qualifying 2 full squadrons at 1,350 feet.
Oh, really?
Because of all these corrections we made in the field. Changes everything.
Huh.
Those were, but that's you get into this sort of stuff where, and I can see where it's ballistic because all the factors involved. You have the drag, you have the imparted velocity, and then you have the drag, and then you have the effect of gravity, and all that.
Air density, that would be drag.
Yeah, but air density determines drag, so that's a variable.
Yeah,
and drag is not a constant; it's a variable.
Right. The shape of the projectile.
Well, yeah, that of course that would be the shape determines how much drag per density. So you have all those variables out there. And I don't know if that's exactly what we're talking about here with Einstein's.
Yeah, I'll have to look